are very excited to be chatting with our friend Tamalee Basu today. She is an amazing person who is a blend of being an architect, a space architect in particular, an aerospace engineer kind of in training. So a little bit of this, a little bit of that. And her passion is to shape humanity's future beyond the Earth. And with her broad expertise, she also merges creativity with technical precision to reimagine our place in the cosmos. And she's not just in science and architecture and engineering. Her passion for space extends beyond art, with her space-inspired works exhibited internationally. And she and I met when she was still a student studying space architecture. So it is really, really fun to have you back at SciArtExchange, Tamalee. I know you've done some things for us in the past, but it's great to see you again. How are you?
Thank you for the wonderful introduction. It always feels like coming back like to friends, and like family in a way. So it's really good to be back, especially with Design Your Habitat Challenge. I think it's a very meaningful and important challenge to start thinking of the next steps of space exploration like that. So yeah, thank you.
We've been helping each other on our journeys, so I really enjoy that. Let me just check with Bryant. Can you hear her? Because she sounded a little bit faint to me.
Yeah, she came in a little bit faint, but it corrected itself.
All right. So, Tamalee, we have so many topics to discuss with you because you have so many interests and skills. So, why don't we start? We are talking here as part of our Design Your Habitat series, where we are engaging people around the world to learn about living and working in space and how we would design future communities in space, and how doing that helps us inform some of our design for living and working better on the earth. So I thought maybe we could all start chatting first about architecture in space and on Earth. And maybe you could kick us off a little bit. What is architecture in the context of space exploration?
So the in the most loose terms, when I think of architecture, I think of any human intervention done to like the physical environment around us, that aids in human habitation, really. And if you think about it, like that's how architecture started, like back in the caves, right, in prehistoric times. And we kind of have to have that sort of an overview when we think about starting a like new frontiers in architecture, which is space architecture, right? When we're thinking about extraterrestrial architecture like space stations or in a different planet like Mars, then you kind of have to think from scratch. So yeah, I think of it like any human intervention that not only helps us survive in those harsh conditions, but also like thrive and, plant the seeds of prolonged human habitation.
So how do the design processes in thinking about developing or designing space habitats compare to how we design how to live in those extreme Earth environments that you were referencing?
Yeah, that's a, in when we think about the two, because the applications are so different, we like automatically think that like one is like must be so much more different, but both of them start like has the same kind of, it's three components really. It's like not my words, it's Vitruvian words of like formitas, utilitas, venastas, and that's how your art architecture starts, right? So formitas is like your functions. So what is my daily life like? That's how I'm gonna live. That's how my apartment's gonna be in art. What is the crew of an astronaut's need for what does the mission needs, and that's what going to create like, okay, do we need a like a greenhouse or not, for example? So that's your formitas. Then your utilitas is, sorry, this was the utilitas. Formitas is the structural part of it. So if
And can you
is
say that
my
word for me again? I'm not catching it.
Yeah, sorry. So there's function, which is the utilitas, which is what is the basically what is the central functions that these habitats are going to be designed around. So what is the life going to be like day to day if it's on Earth or in space, for example? So for an astronaut, that would dictate if you're going to have a greenhouse on Mars, for example. Now, the second part is the formitas, which is your structural integrity of the system. So for Earth, that's very clear to us, right? Like we have columns and beams and foundations and concrete structures that keep the building together, for example. But when we're thinking of space architecture, it's a little different because now all these materials are highly complex. So if you can think of composite materials, you can think of inflatable modules, but these have special processes like stress analysis, for example, and to see if it can withstand the harsh climate. So something that's very similar in space and on Earth is when you're going to design for like harsh environments like Antarctica, for example, you have very cold temperatures and or in desert situations, for example, like there are desert analog mission stations in desert areas. So they have a lot of temperature fluctuations in the between the peak in the day and the like drop at night. So now this gets very much more amplified, as you can imagine, on Moon, where it's like 100 degrees of difference, right? So how do you design for that thermal shock? And then lastly, you have the Venustus, which is the aesthetic part of it. So how can we design a visually pleasing building on Earth? And how can we design for psychological health, for example, in space? Sorry if I went too long.
No, no. So basically, if I understood you, the first thing you do is you assess what functions do I need in this environment, and then you consider the structures that you need. But the interesting thing is whether you're designing on space or Earth, you're going to have different starting materials and capabilities that you can use to build. And in space, there's a lot of talk about using the materials that are there where you are in space. And so those are going to have different properties than what we're used to using as building materials here on the Earth. So you have to consider those things. And then you added in some topics about being pleasing and promoting health and wellness. And we'll talk about that a little bit more in another section, because I think that's a very important aspect of being human. So you talked a little bit about all these different functions and structures. When you're thinking like an architect, how do you think about how all those different structures or systems play together? How does that work in your thinking?
The one great, like a beginning point is, of course, first going to be the functions, right? Like, what is this mission going to be like? What is the duties of the astronaut entail? How does their day-to-day routine like? So then you have, okay, now I need these kind of spaces to support this kind of activities. Then you're going to start thinking, okay, how much volume do I need? Now when you have like, so for example, like just fun fact, I think in microgravity, if I'm not wrong, you need 5.4 cubic meters of habitable volume per person. Now this is going to change as per the different, missions and partial gravity and all these different things. But once we have like these sort of macro units of elements of design, I'm going to say, then we can start thinking about, okay, maybe I need prefabricated modules. Maybe I need an inflatable module because that's going to be better for this kind of a volume. So that now you have more of like the puzzle pieces of how they might come together. So it starts in a more vague, abstract thinking. And then as we define more and more of how this habitat is going to support us, then we have more of a definition of exactly what we are trying to design.
So that's really an excellent segue to another topic that we really wanted to talk about, which is how do you get to kind of that architectural generalized design about the functions and the structures and the general materials to some of those more detailed aspects of a habitat, like how do we design all the engineered components that we need to consider? How might you use our understanding of earth-based industrial engineering to basically design all the tools of a system that are efficient and reusable? And I think Bryant's going to walk us through that topic.
Yeah, definitely. Thanks for having me, Tamalee, and I definitely appreciate your time. But one phrase that I'm always hearing is closed loop systems. And what is that exactly? If you could explain, and how and why has the design philosophy of like rocket engines evolved toward closed loop systems?
Sure. So yes, so Jancy and Brian, you both like raised some very interesting topics. So we start from that macro scale, right? And as we go down to the micro scale, then we're thinking about all of these different aspects of that space architectural habitat or system. And now, because we're starting with such limited resource, we have to completely make sure we utilize every single thing and we're not wasting anything. And anything that is generated as a waste because of the mission operations, we have to make sure we can reutilize that back. So closed loop system is basically nothing but very highly efficient way of reusing and recycling, kind of. But the interesting thing is, as I move through different disciplines of aerospace, I'm seeing different terminologies used for describing something of a very central concept, which is recycling and reusing, and what we call in situ resource utilization, or ISRU. All of these different concepts kind of stem from the central idea of recycling and not creating like any waste that we have to basically just let go of. So with that central vision in the minute scale of like engineering detail scale, if we think about it, then it kind of, in aerospace engineering, for example, in rocket engines specifically, it changes terms a bit, and it becomes more of a closed cycle engine design. Sorry, was I supposed to talk about that now?
No, no. I mean, you can go on. I get it. Like space habitats kind of rely on like reusing resources, that recycling thing. So how can we apply Earth-based architecture to from these lessons? How can we apply that to Earth-based situations?
Yeah, so the idea of recycling and reusing is there in built in architectural processes throughout the industry pretty much. Like if you look at LEED processes, which is like leadership in energy and environmental design, which is basically sustainable design principles for architecture, then it's a quantitative matrix of quantitative and qualitative matrix of understanding if a building or a construction project is very sustainable. Now, this has different parts and segments. So some of the parts I'm just gonna like tell you about one, like one of the biggest one, which is like energy and efficiency, right? And you see that it's very focused on like different kind of strategies of reusing any energy that's used. So like, for example, if you use heating to heat a building, for example, in a very cold climate, what strategies can we use to make sure that like minimum losses happen? If there is any way of getting solar powered or wind powered ways to get that energy so that we're not using a lot of fossil fuel. So renewable energy focus, capturing most of the energy in a most efficient way. So that kind of sustainable processes are used. Now, if you think of the same aspect, but in with the lens of space exploration or space station design, power is one of the like most critical things, right? That is almost everything for any payload, let alone a space station. So then you kind of have to like you have to stay within that power budget, right? So you have to use solar panels, you have to use sometimes small nuclear reactor or something like that. But you have to make sure that the energy is used in the most efficient way. So that's kind of the worst case scenario. And in Earth, we're using sort of more of a milder version of that. But we're using similar aspects to track the overall sustainability rating of a building, for example.
Oh, I see. Like, just to kind of move that along, I'm trying to kind of picture it, and I'm trying to picture myself in my electric vehicle, and it's giving me these, uh, you know, visuals on my dashboard if I'm using too much energy, right? And if I cut it down, it kind of creates a efficiency that I can, draw less from my battery, obviously, and go further and increase my mileage range. So I find it interesting. So with that being said, can you think of an example of like cross-sector design thinking? Like how does a rocket turbo pump and gas turbine share the same engineering principles?
Yeah, so that's a very good example of how we have the same principles of technology benefiting a rocket engine, a space application, but also like a gas turbine, which is an Earth application. And it's kind of like the engineering equivalent of like what we were discussing with space architecture and Earth architecture, right? It's still design. It's still design. It's just a different language of design, right? And so like you mentioned, like the turbo pumps, for example, or gas turbine, both of them, what they're doing is you have a rotating motor, right? So mechanical energy. Now, through rotation. So you're basically using the fluid flow through that to create a thrust, because you're basically manipulating the fluid flow in a way so it's basically coming out in a very high speed. So it's creating that momentum and the thrust. Now, if you have it vertical, it's gonna end up in liftoff. So we watch rocket launches, for example. Now, but if you have it horizontally set up in a way that it makes that thrust is making another set of like impellers and something rotate, and now you have converted this thrust into mechanical energy, which you can store. Now you have a whole gas turbine, basically. But so one is solving energy problems for Earth. Another is solving transportation problems for space. But the technology and I want to say the essence of design of that technology is very similar, because we are starting with now when we're starting with the design for the aerospace, how it helps the actual Earth-based system is because when we're designing the turbo pump for a rocket, for example, it's way more complicated because you have liquid oxygen flowing in, you have liquid hydrogen maybe flowing in, and it's like cryogenic temperatures. And as you're combusting them to create the thrust, you have like this very extremely high, like 2000 something temperature leaving, and you have to manage that thermal shock while it's rotating at that speed. It's just another degree of like complexity of engineering design. And when you solve that all within this like very limited space and mass limits, mass constraints of the rocket, right? Then when you're designing a gas turbine, it becomes so much simpler because, well, we don't have to lift it off. There's no mass constraint like that, right? Most of the time, we're not dealing with as much like stringent criteria, so to speak. So surviving on Earth becomes a lot easier as a result, I'd say.
Yeah, thank you for that. That actually kind of clears something up. some other questions that I wanted to ask. So I appreciate it. We're gonna actually talk about more of the human experience next, and I'll pass that to Jancy.
Yes, I'm very interested. This is a little bit of a tangent from the human experience, but I find it very interesting, your reference to how we use different words to describe the same thing, which adds a little bit of complexity to how we communicate across these different sectors and systems, that you are the poster child for being able to cross those different artificial barriers because of all of your different types of education and experience. But I am very, very interested talking about how does architecture and engineering potentially influence the human themselves. So how might we design in such a way to impact mental and psychological health in both in space and on Earth? I think that's a really interesting question that some people may not appreciate. So what do you think?
Yeah, so the great question. There's, it's the way I think of it, when the design of any space habitat is done very beautifully. So like, for example, um, well, Gateway isn't up yet, so I'm just gonna say ISS is a great example, right? Because you're gonna have to balance both the architectural side of it, but also the space architects have to be mindful of the engineering constraints very, very closely because it's so interconnected, right? And similarly, you also have to be very connected with the psychology aspect of things. Maybe not so much when it's like much shorter mission, low Earth orbit mission, maybe, but it becomes like mission critical when you have deep space missions, especially for Mars or something like that, where the risks are high. The time away from Earth is going to be significantly high. You have three other people like if you're an astronaut in the crew, because that's the first person is a great way to think about design, right? Because if I'm designing for myself, it's probably going to be the best design I'm going to make. So you're stuck with three more astronauts, and now if you want to take a walk outside, you can't leave the vehicle. You're stuck there. Your the volume of Gateway or like a deep space habitat like that is going to be about the size of an RV, so not much space. So how do you tackle that? There's a lot of stress of the job itself. You have isolation because you can't really have a video call like we're doing right now, right? So there's a lot of aspects to this, and design it can be critical in order to mitigate those risks because there's a lot of design principles. So I'm gonna talk about a couple because of our time constraints. But so there's biomimicry, which is a design philosophy that is very, very useful in situations like this, for example, which is exactly how it sounds. It's mimicking biology or nature. So because historically it has been shown that humans generally feel good in nature. And anything that kind of reminds us of nature is generally pleasing to us and our senses. So if we can design a habitat that isn't as clinical looking, for example, and it's more, it reminds you a little bit of home, of earth, of nature, then even though it's not actual nature, we're not inside an Amazon rainforest, it's still going to feel like there's a connection. I'm not so far from home. Um, so yeah, so things like that, I would say.
Yeah, it's a huge problem, a huge challenge, we'll say, because we don't have all the options for open space and easily going from one place to another. We have to bring our own atmosphere and we can't just walk outside. But I'm kind of fascinated, you alluded to kind of the space, the volume challenge. And I was wondering, how do you feel about the concept of humans cohabitating in a tiny little environment? How do they get the privacy or the personal aspect that they might need? How might we do that in a space habitat or a space community?
So one thing actually that's exactly what I was thinking about for a lot of my research area. And one way to mitigate that can be mixed reality or virtual reality. The use of virtual reality, mixed reality in space habitats particularly isn't, well tested, but we don't have too many means of testing these things regularly. But I did a little bit of research on that at the MIT Media Lab, and I was kind of in the prototyping this pod where basically an astronaut could go inside and have a projector-based virtual reality system. And they can sort of, even though it's not completely real, at least they're in a simulated environment where they can choose where they are. It's very important for us to have a sense of place that we have control over. And in stressful situations like that, especially for a very long time, it can help a lot. For now, how we can use virtual reality or mixed reality in places like that depends on the designer, right? That's the part where we need more ideas and testing and research. Most of the privacy related, I would say, initiative that I've seen is, so there is the sleeping pod, there is the sleeping area for any space station, which is completely private. Now, there is like, if I were to design, I would try to find integration of mixed reality systems with areas like that, where maybe you can just get away. And it doesn't have to be exactly that sleeping area, for example, but some space that a person can have their own privacy and autonomy and control of, basically personalization, right, and customization of their surrounding is very, very critical. And now it could be, you could say like a head-mounted display or something might be better, but so I will not try to dictate any design principles here, because I want the participants to come up with their own ideas. But I think that's another very good area to explore, where how can we use technology tools such as mixed reality, virtual reality, or any other tools, like maybe even just lighting, for example, that can do way more than we even think about. But customization of the space around a true individual is
How
important.
about
Yeah.
the other aspect of customization, which is, what do you do in your free time? Those missions to Mars are going to take years, and people can't just be working all the time. So how can you design for the non-work time, the thriving and living, rather than just the surviving and working?
So I would think about it. I would not answer the question completely, because again, I don't want to, give any like definitive answers, but I would hint at some areas of the design process that will be very fruitful. So if you study like the astronaut schedule, um, then you find like they spend a lot of time on exercise. Um, so you have the treadmill, you have all of these things that you have to do for like 2.5 hours, I believe. 2 to 2.5 hours. I'm forgetting the exact time. But because in microgravity, what happens is the bone density there's a loss. So especially for long exposure. So in order to mitigate that, humans have to like work out way harder than we have to on Earth. So now, because we know that's a fun activity that they're going to do regardless, there's a lot of leeway of how can I design this space and make it a very enjoyable experience. So no matter how stressful the rest of the duties may be, maybe I can't leave space other than like the vehicle, right, for like very stressful spacewalk. So that's not relaxing either. But now that I have this time of physical exercise, which can be healing, it can be psychologically healing as well. I saw there is like some research done with like well, sorry, I'm forgetting the exact topic, but
We were just talking about, how do you design in entertainment for the time when people are not working on those super long missions? And you touched on exercise, but which, I personally think is very well being promoting, but people need other things to do as well. And I was just asking what your thoughts were on that. And it is okay to say exactly what you think, because this is an opportunity to hear from an expert on, their knowledge base. All of this will help support anyone who wants to create something themselves for design or habitat. I don't think you're gonna ruin anybody's individuality with your words. I think you're gonna inspire them.
okay. So yeah, thank you. I would say then, so okay, so the exercise is one avenue, right, that you can play with. There's the other aspect of greenhouses. Like that's a little bit of like my personal opinion, so take it with
Please.
a hint of salt. But like when we think of greenhouses or like the experiments that have been done so far, it's more to like, yes, there's a big chunk of it to like document results, right, for biological experiments that we can only test in microgravity, so on and so forth. But when we think of long duration habitats or like long duration human settlements, then we actually have this chance of, it's the same thing as why people garden in their backyards. It's cheaper to go and get groceries, right, from the supermarket, but we still choose to garden. There's some healing quality of that, seeing that green, growing it. So how can we design greenhouse with that uplifting sort of experience in mind, rather than completely for like we're creating hydro aeroponics or something and like everything has to be engineeringly sound. Yes, that has to be done, but also how can we design it so the experience in itself is healing? Another aspect I would say, which is the only other thing I can think of for like enjoying non-work time, is playing with the gravity itself, because you can actually have microgravity, partial gravity, fun games, for example.
Maybe we could create new, like, whole sports that you can do
Exactly.
only in microgravity.
Quidditch, maybe possible. We don't know.
You see the
So
astronauts playing on the ISS, so why not?
right. So that I think that's the other thing. Like we don't know, because so much less has been tested. We don't know exactly what's the variety of sports that can be played, right? That's an exciting area.
And I think there's another area, and you would be a great candidate for this as well, which is to think about how the arts themselves could be conducted in space. I think in some previous conversations you and I have had, and I've had with others, we've even talked a little bit about what kind of art can only exist in space, because the creation of it maybe needs the microgravity environment, or it needs special materials that you can only get on the surface of the moon or Mars. So and I'm using the term arts loosely, visual, musical, literary, how might that help with designing for well-being as well?
That's a great point. One thing I will like mention is that you can definitely use, again, like I'm gonna think of microgravity first because that's your most extreme kind. So there have been like experiments that are done where I think it was MIT Media Lab's experiment where they basically tumbled I think a piece of charcoal or something inside a box that was lined with paper in microgravity until it floated around, and that's the pattern that it creates. But we have had like historically as well, like in Voyager, right? We have used art to express ourselves in the context of space exploration. Now, there are like I had this idea and I would love to test it out at some point. This is again like it's not research. This is just me. But I had this idea, like you have such high levels of radiation in space. You have galactic cosmic rays, there's no atmosphere, so nothing's stopping it, right? So so at the end of the day, what is radiation? It's like these high frequency waves that's just hitting particles or materials. So different materials will respond differently to this kind of waves. So now we can think of space radiation if we just think about like space radiation as the medium creating the artwork and the paint being the different materials that react very, very differently. Then now we have a visual art medium that may not be possible, like definitely not possible on Earth because of our atmosphere. So now we have an artwork created in space, and astronauts whose day-to-day life is mostly engineering now are becoming artists. So now we're blurring the lines, and that's beautiful. So
That is awesome.
That is awesome. I had a question. Like, if I was to go into space right now, would I be a better artist if I painted the same thing?
that's a great question, like because there's the overview effect.
Yeah.
So was it David White? I'm forgetting his name.
Frank White.
Frank White, thank you. Sorry. Oh my God. But so he talked about overview effect, which is basically you see Earth from space and you realize how fragile all of this is. And this awe sorts of sets in, and you have a renewed appreciation for life on Earth, right? And I think like I'm a big fan of Nicole Stott. So I think she made beautiful paintings because inspired by space, I believe, right?
Yep. And that's a great segue to another topic we wanted to talk to you about, which is let's talk a little bit more of the role of artists in the space sector. And I think Katrin's going to walk us through that.
Well, I almost, thanks, Jancy and Bryant and Tamalee. I almost think like we've all gone into more the actual arts portion of it. So, thinking about that, but also thinking about the science and the engineering and space exploration, but turning it out on its head, how are the arts, and as Jancy defined, that could be broadly, how are they essential, in your opinion, to space exploration? If you think they're essential, maybe they're not.
So I've thought about this question a lot, because, I started painting since I was 3. Like I started painting before I started talking, right? Like I might be wearing a hat of an architect, aerospace engineer, whatever, but at the end of the day, that's my first language. So I think about this question a lot of like, what can I bring to space industry? And so I think there's phases. I think the first phase of an artist or any art really, performing arts, however you think of art, is to inspire. Because when we think of space exploration, it's like magic. We don't know so much versus the amount we know. It's might as well not exist. It's so unknown. So when we're setting out for the unknown, we don't have much things to hold on to. So any kind of vision, any kind of performing art piece, musical piece that can bring that feeling closer, it can be a guiding vessel in order to proceed in the design process or, visualization process.
Yeah.
And then because I'm a visual artist, I can't sing. So then I think more about how a visual artist can help in space, in the space industry in general is, so say I have a vision of let's say a closed loop system that is completely self-sustainable. And I think of it like this bubble that's floating in space. Now, a bubble in space is not a realistic vision, but it is something to express my starting idea. So now that I have this idea, now I can think about, okay, what things don't work? Okay, a bubble, probably not going to work. Probably I'm going to need some kind of a container to put people inside of. So now, okay, now I have one element. Now I said people. So now I can start thinking, okay, how many people? So now I'm actually thinking of this vision in more tangible terms, like real small physical parts of it that I can actually engineer and design for. Now, as I keep hammering in and like chiseling out the little pieces of design, basically, and like getting more and more clear on this vision, if we keep going at it, we're going to arrive at this point where it has become this construction drawing, basically, or like a blueprint,
Right.
where we have basically have figured out all the nuts and bolts and layers of Kevlar that the material are keeping the things together, and all the clamps you need to put those things together. Like we've imagined to that level of detail. Now we've arrived at the start of actually building it. So yeah, so I think the art is everything. Like we might call it shop drawing, but it's still drawing. It's still art.
Right. Well, as you were talking and you're talking about how especially visual arts can help one think about all the different possibilities and then bring it forth to a more concrete and realistic way. What it made me think about was other scientific principles, especially for space, that are complicated. And are there other art forms that could help explore that or inform on that? So, could theater in some way, as you're imagining or visualizing, is there a way through theater or music or dance? Because that's also sort of abstract and expressive. I mean, I realize this is not something that's necessarily used, but just wondering about your thoughts on that aspect.
I think that's a great question. Honestly, I'm not like a truly expert on that, but it's a very good question because it brings me back to what Jancy was talking about the fun part, the entertainment part, right? So I think even for performing arts and things like that, like non-visual arts, for example, it can have two branches. One can be the initial part or the outreach part, right? Where it inspires you. So like David Bowie songs, for example, like that you close your eyes, you listen to like a David Bowie, you're in space. Like you might not be in space, but in imagination, you're in space and it brings you really close to that experience. And then there's the other aspect of it where you're trying to express what you learned or you're processing the information you're gathering in space, or about space, for example, which reminds me of this. I'm forgetting his name, but there was this choreographer, I believe, who I think did performances in parabolic flights or something like that to inside the simulated gravity microgravity. Which is because you can only hold those poses and stuff in microgravity, right? Because you're floating, which is crazy. Now that kind of ties me back to what Jancy was talking about, like what we talked about the sports part, we talked about the games part, but we can actually come up with design dance forms that can only exist on Moon. Because you can only jump that high in a sixth of gravity on Moon.
Right.
And so these are art forms that can only exist in space.
You said that, I thought about Peter Pan, and you could really have Peter Pan and Wendy flying where you can't do that in gravity. So that, yes, that certainly would be that would be fun. I want to be in that play and be one of the lost boys flying in that one.
Or the new form of ballroom dancing or ice
Oh,
skating, except that it's in zero gravity and it's like
yeah.
couples dancing, create
Oh,
a
or
whole
what's
new
is it? The swing dancing where they're swinging them up in the air and
Don't let go.
And like that's the beauty of it. Like we're thinking of it artistically, right? But now if we want to create like a really complicated, maybe a huge jump or something, like somebody gets thrown away at some point, we can calculate this trajectory, guess what? Using engineering principles.
see that, and that ties into what another topic was about how art plays into designing, and that sort of use brought us full circle there. We're talking a lot more about inspiration, and I'm wondering if any of these things that we were just talking about would play into the survival in space. I don't know that it would, but I think that it's interesting to imagine.
So I think for the survival part, I know very well about the visual arts part. So I'll start with that. Because so yeah, so when we're in the process of visually imagining a habitat, right? I'm just gonna say because we're designing habitat. Um, then we're starting with this space of inspiration and we're imagining what is the best case scenario that we can have. Now, as we're shaping it with, okay, we're gonna have this in maybe this orbit, maybe not low Earth orbit, maybe in high Earth orbit or something. What does that mean in terms of radiation? Maybe we need this thickness of layers of the vessel, for example. So now we have a thickness, we have a volume. We can draw the different components more accurately. And as we're in this process of visualizing all the little details that goes into the system, then now that is the time we're going to start thinking about the survival, right? Like, are there any gaps? Are all the interfaces connecting properly? What happens if there's a fire? Is there enough dimensionally? Is there enough space for an astronaut to move quickly? Is there any obstructions? So we don't just like draw it 2D, right? Like, so we develop 3D models. We use like those software to kind of go through it, and then all of a sudden we're actually helping mitigate those kind of risks and making sure survival is taken care of.
Well, and then I just thought about, as you're developing this, one of the ways to fix things is somebody throws the other person up into the air and they can then do a backflip. And anyway, I'm being silly. Thanks, Tamalee. This was such fun to talk about the arts in space and visual as well as other types of art forms. I really appreciate you being here. And I'm going to send it back to Jancy.
So I actually have a question, and then I wanted to tie things together a little bit. My question is, we've been talking about the interplay of architecture and engineering and the arts and how that allows us to not just survive, but also thrive and be well in space, which I think is really, really a fascinating question. And we've talked a little bit about how, how that works in space. Going back to that, just that terminology of the closed loop, I think it's really clear for anyone listening, how there's a closed loop in space because we know that we can't survive in that environment naturally in most places throughout the universe. Do you think it would help us to think of Earth as a more closed ecosystem? Would that in some way help us to live smarter or design how we live any better? I'm just curious how you feel about that.
Yeah, absolutely. I think that's at the basis of sustainable thinking, really. Because if like the most rudimentary definition, we are on a spinning rock. It is a spaceship in a way, and it is a it is a closed loop system. So if we're not careful of how the outputs are going back into Earth, and if not enough inputs are there, so resources like clean water, etc., then we don't have a means of getting it outside. So I think when we're designing a space architectural system or like a space habitat, we're basically just creating a microcosm of what we already are in. So it's just the time buffer is a little longer for it to catch up with us, but it's there. So I think in a way, exercises like this, design your habitat, for example, is very, very critical because then it challenges us to think of a much shorter time frame before the resources run out. So then we've designed for like a minimum viable product kind of a thing that has to work. And because the risks are so high and because the systems we have to develop are in such short budget, it's much easier to be scaled later on Earth, where we don't have that kind of a resource shortage. So yeah, I think it's important to carry that design philosophy with ourselves from the exercises like this, because then you're more careful about, not keeping the light on where it's not needed, for example. We're more cautious and careful about how we're using our energy. And like, for example, just to give like one last example, think of construction methods, right? So if I try to create something on Earth, 3D printing isn't like, it's not that, I mean, it is accessible, etc., but it's not the first go-to. We can just like, let's say I want to build I want to say like, let's say a truss, like a small truss frame to hold something up. My first thought is, oh, I'll just go to like Home Depot, get a pipe, cut it up. And if I have a few extra spare parts that I toss out, it's no big deal. But in space, I have to get that whole pipe, launch it. So I'm paying for the whole mass. I can't waste it. So now 3D printing becomes a very important tool because we can use all of the filament in infinite different ways. So yeah, so I think there's a lot of lessons to be learned through exercises like this.
Well, thank you, Tamalee, for your insights. I think we all really appreciate your taking the time and blending all of these different experiences and trainings that you have. Once again, I can say you are the poster child for SciArtExchange, more so than many other people. And I would like to, before closing up, I would invite our viewers to please follow SciArtExchange on social media and also subscribe to our newsletter, which will allow people to see more examples of people like you and people who are using all of this interdisciplinary thinking to do great things on Earth and in space, and also to invite them to join and participate in Design Your Habitat 2.0. So that would be really excellent. So in general, I think what has really bubbled up from listening to you talking about your experiences is that great things happen when you can really encourage cross-sector thinking and collaboration, and it allows us to accomplish and contribute more. And maybe I'll just end on kind of the following note that what you have underscored for us is that designing on Earth helps us build for space, but building in space also teaches us how to better design for Earth. So thank you very much for that.
Thank you all. I feel really honored to be here, and it's a great engagement whenever I get to connect with SciArtExchange in general. And congratulations, this is a great project.
Well, you were there for Design Your Habitat 1.0 as well, so you're the gift that we never let go.